So it means there's going to be 2 files sent. All right. So the next one is evaluating limits by rationalization using the conjugate. So I'm going to express that. So we all understand this. We're driving into limits. We're driving. It's a big journey, but we'll get there. Hey, we're in our last hour. Okay, I'm not, we call this rush hour, but oh my God. All right, so yes, in the previous sessions, we talked about how we learn how to solve limits by factoring. Now, the thing is that not every expression can be factored. Okay, not every expression can be factored. Sometimes the expression contains square roots. So like we have, for instance, let's say you have, this is evaluating limits by rationalization. So evaluating limits by rationalization. Don't worry, you're getting the good things about limits. When we finish limits, we can then move further into other topics, or we hit differentiation. But I need you to understand. So sorry I had to go through this journey, but it's good now. You guys have solid foundation in all these things, functions, limits. You're going to tear it. So from now on into the future. All right. So let's say we have limits. We have something like this. We have a limit of square root of x minus 2 over x minus 4. And then as x approaches 4, so if we substitute directly, we're going to get 0, indeterminate. In this situation, self, factorization doesn't help. What do we want to factor here? Factorization doesn't work. So when you see that direct substitution is not working, factorization is also not working, you switch to rationalization. When you one secret about rationalization, when you look at the things and you see it can't be factored, you're seeing square root and order, boom, enter rationalization step. Don't waste time, don't think about it, just go in. So let's imagine you have two identical keys. One can open a lock, the other one can close it, but they work together perfectly. That's how conjugate works. In rationalization, we have what we call conjugate. Sorry. So in rationalization, we have what we call conjugate. Conjugate means it's a pair. There's a positive part and a negative part. A conjugate changes only the sign in the middle of an expression, especially the one that cannot be factorized. For instance, let's say we have an expression. I have an expression like this. Okay. And then I have a conjugate. Root x plus 2. And let this be my conjugate. The conjugate is root x will be root x minus 2. If I have root x minus 5, my conjugate will be root x plus 5. If I have 3 plus root x, my conjugate will be what? 3 minus root x. If I have 7 minus root x, my conjugate will be what? 7 plus root x. Like, are you saying? This is conjugate. It's kind of like it's flipping the sign, but you need the pair, especially when you want to rationalize. Only the positive changes to negative and the negative changes to positive. That's how it works. Everything else stays the same. Why do we use conjugate? We use conjugate so that we can arrive at a difference of two squares. When we arrive at a difference of two squares, when a square root multiplies a square root, it cancels out. Remember when we're trying to look for this, when we say x squared equals 25, and then we square root both sides, and we say the square root cancels the square. That's how it is. Because when you have a square root means something raised to the power of 1 over 2, according to the laws of exponents. Did it last semester. So if I say square root and then I multiply this, or I square the square root, it means 2 will cancel 2, and this means x raised to the power of 1, which is just x. That is why square root always cancels square. Square root means raised to the power 1 over 2. When we have square, it means 2 times 1 over 2, which is 1. And then we're left with just what is inside, which is x. So by the time you multiply a root and a root together, you just have the value that is inside. For instance, let's find the conjugate of this. Let's say we have the square root of x minus 2, and then we have root x plus 2. By the time you open this is root x times root x. So what root x times root x means is this. Root x times root x means x raised to the power 1 over 2 times x raised to the power 1 over 2. And according to the law of exponents, when you're multiplying, the indices, they add up together. So this is x raised to the power of 1, which is just x. So that's why when you multiply, this means when you multiply the roots together, you only get the value inside. So if I have something like this, it means that I'm going to have my answer of this and this is going to just be, the difference of two squares is going to be x minus 4. By the time I open it, the square root disappears. So once you see that square root, don't reason factorization. Go straight into rationalization step. Write out the conjugate. Multiply the numerator and denominator by the conjugate. Simplify, substitute. Boom, you get your answer. So let's deal with this question. This one says that the limit of root x minus 2 over x minus 4 as x approaches 4. So what I'm going to do is I'm going to get the conjugate. So limit of root x minus 2, let's go. So we have this to be the limit root x approaches 4 bar. So this now, what I'm going to do, I will multiply it by the conjugate, which is root x plus 2 over root x plus 2. That's what you do. That's how you rationalize. Both the numerator and the denominator, you multiply it by the conjugate. And then you open up. So what this means is root x minus 2 times root x plus 2. And that's like difference of 2 square already for the numerator. And then we have the one for the denominator. So the denominator will be x minus 4 times root x plus 2. We're getting there. So now this would be what? Just x minus 4. I hope you understand how we got that to be x minus 4. Look here. See, that's what we did. When I explain, are we following?
Never click on.
Never click. You must click. Oh. You must click. All right. So tell me which part? Where cut you off? Which side?
From where we express the x minus 2, the square root of x minus 2 multiplied by square root of x minus 2 again, becoming x minus 4.
Okay, we said square root of x minus 2 times the square root of x plus 2, the conjugate. You see that it's the opposite.
Okay.
So if we multiply that, you know that root x times root x is x. You understand that factor?
Okay, by multiplying means it clears off the the square root sign, and you are left with the value alone.
Exactly. Square root times square root will cancel out. When square root multiplies square root, the square root goes away. Only the value that stays. That's what we explained here. Square root means 1 over 2, raised to the power of 1 over 2. And then the other one is raised to the power of 1 over 2. When you add them together, it means x raised to the power of 1, and which is just x. You're left with just that value.
Okay.
And then you have root x times root x, which is equal to just x. So here now, when you have square root of x times square root of x, you're just going to have x. So this is like difference of 2 square. If you notice, you have minus and you have a plus. That's the difference of 2 square. And they're having both perfect squares. 2 times 2 is 4. If you want us to really express it, we can express it. Root x minus 2, root x plus 2. Root x times root x, and then root x times 2, minus 2 times this, and then this times this. So root x times root x. Then we have root x times 2. Then we have minus 2 times root x. Then we have minus 2 times plus 2, right? So root x times root x, x, plus, this will give me 2 root x minus 2 root x. 2 root x minus 2 root x cancels out. It's just like you saying 0. And then minus 2 times 2 is 4. So we have x minus 4. This is how we express. But it's
Sorry, let
difference of 2 square. Okay? You with me?
yes, please. I'm trying to write back this very expansion.
Okay, the expansion, yeah. So it's difference of 2 square. So I gave us the shortcut that the square root will cancel, and we already understand difference of 2 squares. So we just put it out. So that one is going to be x minus 4. Then we continue with the denominator as we multiply that. So you see that x minus 4 would cancel x minus 4. And then we're left with 1 over. Okay, let's continue. Just let me know when we can go on.
Okay, I'm still right.
Okay. Yes, princess.
Okay, this multiplication here, okay, root x times root x is x plus root x times 2, that is 2 root x, minus 2 times root x, that is minus 2 root x, then minus 2x plus 2. 2x
That's
plus,
minus 4.
yeah, what about the x?
No, minus 2 times plus 2. That's it you're seeing here, right?
Or the x?
Oh, this is which x? Is it the root x?
Okay, this is 2. Oh, I thought it's 2x.
2
Oh,
times plus 2. Yeah.
okay.
All right, so let's let's hit on. Wow, you guys stayed till the end of this marathon. That's beautiful.
Sorry, the for the where we have x minus 4, and is that the end for this very
That's not the end. I only allowed you to write the
okay.
yeah. So that's not the end. I do have under every part there are like practice questions. I have under it's like a lot, but that's for mastery and classes and all that. Okay, so let's continue. Mm, so for this one now, we have x minus 4, right? And then we're left with, let's continue now. We're left with, we have this to be x minus 4, parenthesis, with x plus 2. X minus 4 cancels out, so this is 1. Let's continue down here. So we have the limit to be equal to, so excuse me. So we have the limit to be 1 over square root of x plus 2, and then we just, okay, this is for the limit as x approaches 4, right? And so we substitute now. We have 1 over root 4 plus 2, and that is equal to 1 over 2 plus 2, and that is equal to 1 over 4. Answer 1 over 4. So that's it. Before you get to L'Hopital, because a lot of people just want to jump into L'Hopital, but that's not how I handle my things and all that. So I need you to master this limit. When you're done with rationalization, you will then treat trigonometric, solving with trigonometric. Okay. You will see why rationalization works. You then treat special trigonometric limits. When you're done with special trigonometric limits, you learn about the sin x. You learn how to use calculator and solving in radians and all that. So after that, that's when you now learn L'Hopital. In fact, before you even go to L'Hopital, you need to master or learn limits at infinity, where you have positive infinity, because Danjuma made mention of that, positive and negative infinity. Then you can now get to L'Hopital. But okay, let's see something. Let's see something. Can we answer this question? Answer this question for me. Evaluate. Let's test. Evaluate. We have the limit 3x squared minus 5x plus 1 as x approaches 2. What's our answer, please?
I got one though.
You got one?
Yeah, my answer is 3.
Okay. Someone's answer is 3. We have 1, we have 3. Another person?
Got 2.
Okay, 2. All right. So let's solve it and see. So you can use direct substitution, right? Because let's try with direct substitution. If I put this 3 parentheses 2 minus 5 parentheses 2 plus 1. So this here is 12 because 2 times 2 is 4. 3 times 4 is 12. Then minus 10 plus 1. And that is 3. So answer is 3. Do we understand that?
I thought the other one is 5x to the power of plus 1.
Hey, Jesus. Plus 1 equal. It is 3. Sorry. That's from me. Okay, so the answer is 3. But do we understand it?
I
So
don't know. I don't understand.
Okay, so 2 square means, if we say 2 square means 2 times
Yeah.
2, right? That
Yes,
is
I
4.
get this from there. I'm talking about this 12 minus 10 plus 1.
12 minus 10 is 2. 2 plus 1 is 3.
Can you also factorize this? Like if we were to solve it using factorization?
If you solve, once direct substitution can go, it means it's not an indeterminate form. We use factorization when we have indeterminate form. Okay, but if you're going to factorize, you're going to pretty get a little bit confused because this one now is going to give you 3x squared.
Okay,
Then you
so
start looking for values that are going to give you -5. The question is, can this equation be factorized?
so I was considering if there is going to be like a shortcut to quickly determine which one is factorizable and which one is not, so we can just know the right method to just go straight to it. So
You want to check if
I understand that if
okay,
it has the square root and all of that, you should consider using the
rationalization.
rationalization. And if you can factorize, then you should use factorization method. Is
Yeah.
that
So the question is this factorized? Can we factorize this? Can this equation be factorized? When you want to check if an equation can be factorized, use determinants to check. Determinant is b squared minus 4ac. So just use that to check. My b is my -5. And then minus 4 parentheses, I have 3, and then I have 1. A is the coefficient of x squared, b is the coefficient of -5, 1 is c. So this is like, if it gives me a perfect square, then I can factorize. So this is like 25 minus 12, right? And that is giving me 13. This is not a perfect, I can't factorize it. So when you look at the equation, you then check, can this thing be factorized? Can I factorize this equation? You can quickly use the determinant formula to know. That's like pure maths, just checking and all that. So you can quickly use the determinant formula to know if this can be factorized or not. Okay. So this one can be factorized. If I use b squared minus 4ac sharp, I use my calculator, so I see it's not giving me a perfect square. I'll just use direct substitution. Insert it, and if I see direct substitution works or something. But when you look at it, your eyes will start fixing it in. As long as you've gotten that straight understanding, your eyes will fix the entire thing in. You get? So do we have any questions? So this can be factorized. Any further questions? Are we good? All right, that's great. That's great. So this question is also from the test. It's part of your test questions from the LMS. Yes. What's your name? Princess, you wanted to ask a question. Are you clear now?
Yes, yes. I was on. I made a mistake.
Okay. All right. So let's continue before we go into limit set. Now we're going to take it one step at a time. So maybe I should just go and write the textbook, because why not? So let's try this other one. Let's say we want to evaluate an equation like this. That one I just brought it out from the test. Wanted to give us one or two throw-offs. So say we have to evaluate, we're asked to evaluate the limit x if we have root x minus 3 over x minus 9. So first things first, we multiply by conjugates, right? That's the first thing, multiply by conjugate, and we check it out. So let's multiply by conjugate. So if I want to multiply by conjugate, I have root x minus 3 over x minus 9 times root x plus 3 over root x plus 3. I rationalize, and so let's go. So this becomes difference of 2 square. I have minus 3, and then I have root x plus 3, and then over I have x minus 9 times root x plus 3. And then this one becomes root x times root x cancels out this difference of 2 square. So I have x minus 9. Yeah, that is x minus 9 in this part here. And then I have over, please, do we now understand how I got the x minus 9? X minus 9, and then root x plus 3. And then this cancels out. I'm left with 1 over root x over 3. So 1 over root x plus 3. Remember the limit. We have the limit as x approaches what? 9, right? Okay, as x approaches 9. So this becomes 1 over root 9 plus 3, and that is 1 over 3 plus 3, and answer is 1 over 6. Okay, do we understand that? Question? Rationalize by conjugates. Question? Do we have any questions? Are we clear?
Sorry, can you hear me, sir?
Yes, I can hear you now. Yeah.
Okay, so around where we are multiplying by the conjugate, where we have root x minus 3 multiplied by, is that x? Yeah, x plus 3
Root
equals
x
to,
plus 3. Yeah.
is root x plus 3 again. Around where we
Root
say
x.
equals to x minus 9, then divided by x minus 9 multiplied by root x plus 3. Is that 3?
Yes.
It be.
So we are multiplying by the conjugates. It goes both numerator and denominator. That's how you rationalize. So it is root x plus 3. So this is difference of 2 squares. Square root will cancel square root. We're left with only x. 3 times 3 is 9. Because it's difference of 2 squares, that's why I can easily put it like this. Put it out like this as x over 9. X minus 9, rather. Same explanation we had in the previous board, where we had to deal with this, and we had to express as x minus 4. You see that?
Okay, we multiply both the numerator and the denominator by the conjugates.
By the conjugate, yes, that's how we rationalize.
Okay, so the conjugate is simply the is only the sign that change.
Yes, and the
Between the,
conjugate only sign changes. Yes.
okay. But when we have in brackets root x minus 3 multiplied by in bracket again root x plus 3. We now end up having x minus 9 for that. So it's
Yes,
because
it is x plus
the square root cancel out and okay.
difference of two squares.
Okay.
Are we clear? Do you have further questions? Hello?
Is anything on? Yeah.
All right, so it appears we're clear.
Is anything on there?
Okay, so let's try this other one. Let's evaluate.
Yes.
Hot mic, hot mic, hot mic. Let's evaluate. We have the limit of root x minus 5 over x minus 25 as x approaches 25. So let's do this. Let's solve. What's our answer? What are we going to get? Another person should solve this. As one is solving this, another one should solve the limit of root x minus 1 over x minus 1 as x approaches 1. As one person is solving that, another person should solve. Yeah. It's kind of like rush hour. We have the limits. It was nice spending time with you guys. As it approaches 16, we have root x minus 4 over x minus 16. Okay. Yes. And then another person should do the limit of, what if we have it like this? Let me exchange it over root x minus 2. Let me exchange it. And x is approaching 4. Yes, Chris.
I'm sorry. I was drifted in a bit, so I didn't get to copy the last solution you gave.
Okay. So we have 4 equations there. I need 4 volunteers. Help us with it.
Let me just get the last one first.
Okay.
Okay.
I saw this one.
Okay, yes. What's the answer? What do you have?
I have a 30.
You have what?
30.
30. Okay. That is the one for root x minus 5 over x minus
5.
25.
Yes, exactly.
All right. Okay. Does anybody have something, any other answer for that, or we're going with 30?
Yeah, I have 10 for the same question.
You have 10. That's
Yes,
your answer.
yes.
I got 1/10.
Actually, Princess is correct. It's 1 over 10.
Yeah, that.
Um,
Oh,
These guys are leaving me behind. Oh, sure.
who is leaving you behind? Oh, I beg. All of us, the okay. So it's 1 over 10. We're going to write out the correction for that. Yep, 1 over 10. Okay, so have you seen your mistake? Or let's solve it. Should we solve it? Let's solve it together. All right, so that we can save time. Yeah, I think this is where this is where our bridge cross. So, hi. Yeah, 2 more journeys to get to Lopita and enter differentiation. What about continuity and discontinuity? Okay, so let's do it. Let's do the first one, which says the limit of, it says the limit of root x minus 5 over x minus 25 as x approaches 25, right? And so we have the limit of x minus 5 over x minus 25 as x approaches 25. So I just simply multiply by the conjugate, both the numerator and denominator by that conjugate. And then here I'm going to have root x minus 5 and then times root x plus 5. And then I have this to be, so if I open this difference of 2 square, I'm going to have x minus 25 over x minus 25. And then I have root x plus 5. And so this cancels out. I'm left with 1 over root x plus 5. Remember the limit approaches what? 25, right? So the limit approaches as x approaches 25. So I got, that is 1 over root 25 plus 5. And that is equal to 1 over 5 plus 5. And that is 1 over 10. That's our answer.
Oh, it is my bad. I swear I got it wrong.
Okay, do you see the mistake? Do you see a mistake? Have you seen it?
Yeah, I changed the value. Instead of 5, I wrote 25.
Hi. Yes, yes, yes. That's right. Let's attempt the second one. Does anybody have the answer for any of them? Have you done any? Which one? Let me know.
Okay, I got 1/2.
1/2.
For this,
That is correct.
oh, great.
Our princess just the hot. Just the get everything. Okay. Let's evaluate.
Abeg, help me put the previous solution you gave, please.
Okay.
X minus 25. Okay, so can I just have the other questions and then the answers, then I can just solve it later.
Other question. These are the other questions. This is 1. This is 2. This is 3 here. That's
Oh,
4.
oh, he's even right in front of me.
Yep.
Okay, let me just take it down, please.
Right. You're writing seriously.
X minus 1, H, X minus 1 as X approaches 1. Okay, so the third one is X minus 4.
Yeah, I got 1/8.
1/8 is correct. Omo. Hey, hey. Oh yeah, now.
Which
I'm
of the
just
hot?
happy
Which
you.
of the hot?
Omo. She no even they give anybody space. She just they write it in a go. Okay.
Why are you go down for exam hall?
So what about the fourth one? I exchange it. I put that one down. It's the same thing. You multiply by the conjugate. Put the numerator and the denominator by the conjugate. It's just that the down part is going to have the difference of 2 square. So it won't be easier. Well, it's good that we're getting it because it means that we have a clear understanding about rationalization. It's just that we have 8 minutes left and it's a pity time far spent. Although I do have my own my mentored class. I think one of us is here. Some of my other private students they couldn't join. I don't know because they know I'll give them that recording of you. But Ishak is here. Ishak is part of my private class student. So we're still going to treat all these things. If you want to be part of the private class, you can reach out to me on WhatsApp or you
Sorry,
send.
my network is breaking.
Oh, Ishak. Yeah. No, I was just telling them you're part of my private class student. You're part of us in the private class. And if they need to, if they want to join, like, because we're going to continue this to finish. You know how we roll now, right? So we continue and we finish till we finish all the topics inside and we clear it out. Same thing with physics and physics practical. So just in case you wish to continue, then you can reach out and you join the private class. But anyways, I really enjoyed the time I spent with you guys. But the time has not yet elapsed, so let's continue. Any further questions? Are you done writing, Chris? We need to push on, like use the remaining 6 minutes here. And no, the one for tomorrow is physics, so it's not paid, it's also free. It's like we're going to continue. So if you want to continue on, because Monday I'll be hosting marathon classes, but that'll be for my private students. So we would finish the entire thing by Monday and all that. But tomorrow is physics. So we just cover what we can cover. What I want is deep understanding from start to finish. And so you have the entire understanding. When you're going for your exam, you're going with confidence. You know what you're doing. When you see your questions, you're just happy. You know, I've got testimonies from my previous students, Ishak being one of them. I'm just happy you could join us tonight. Well, anyways. And then, you know, so you won't be
Sorry.
frightened. Deep understanding and foundational knowledge. Yes.
Okay. So I just want to know the answers to the last three questions so I can validate it when I solve them.
All right.
The
So Princess helped
X
us.
minus
Princess said the first one is 1/2, and she said the
for
number
the
3 is
for the
one
X
over
minus one.
eight.
1/8, and the other one is 4/1, I guess.
Number two is what? Number two.
Number 2 is 1/2. Yes, Ishak, you're
1/8.
correct. 4/1
Ah,
is this one.
Okay. Number three is
Number 3 is 1/8. Number
over
2
eight.
is 1/2. Number 4 is just 4, or 4/1. Yes, Ishak, you're correct. You see, you guys have the understand. Oh God, this is beautiful.
The number one. The number one is sorry.
Oh,
Is
number
it
1 we
the
sub it together. 1/10.
okay? So the number two is the x minus one over x minus one.
Yes, that's 1/2. Yeah. So the journey continues, but
Okay.
that's going to be Monday when we continue. After rationalization, we keep going into special trigonometric limits, and then we treat fundamental trigonometric limits, and we go on to
Please,
treat.
this last one. This one you can't.
Yeah.
I don't understand it. Oh.
Oh, we just exchanged it. Then we treat limits at infinity. Okay, so we exchange it. For the last one, let's deal with the last one. Last one says that, what's that question again? It says evaluate. So evaluate x minus 4. Evaluate the limit. We have a limit x minus 4 as over root x, I think, right? Okay, yeah, over root x
Yes.
minus 2 as x approaches 4. So we just multiply by the conjugate. We rationalize by multiplying by the conjugate. So this would be root x plus 2 over root x plus 2. Okay. That's what we do. Multiply that by the conjugate. Then we go on. So this one now is x minus 4 times root x plus 2, right? And then this one is difference of two squares. We have root x minus 2 times root x plus 2. And so if we continue, we're going to have x minus 4, and then we have root x plus 2 over, this would be x minus 4. It will cancel out. Remember, square root cancels that. So this will cancel this. We're now left with this root x plus 2. And remember the limit. The limit is as x approaches 4, right? So we have root 4 plus 2, and that is 2 plus 2, and that is equal to 4. That's it. Okay, so do we understand that? All right.
So, what are we supposed to cover throughout the day? Are we supposed to cover the entire mathematics if on a normal situation where we're just moving ahead?
All right, so what we're going to cover, all right, this mass, according to the questions brought out in our LMS, because my strategy is from all the questions, all the topics that they set out in that test element, they're going to expand on it. Functions and limits, one of them. So what we're doing, we're learning functions and limits. Then the next is differentiation, rules and techniques. Okay, differentiation, rules and techniques, previous part. All right. Then we have applications of differentiation, integration, foundation, and techniques. Then we have definite integrals and application of integration. So these are where the questions came out from. All the questions from the test elements, these are where it came out from. Those 5 parts. So I divided into 5, and then my strategy is teach the entire foundation, understand it deeply, so you don't have any, you can't shake no matter what. They gave us a total of 41 questions. Yes, Princess. Princess?
Please, that last one, can you re-explain it, please?
All right, so let's, I think Praise is still writing. Praise, let us know when you're done. So
Yeah, I'm done. I'm not writing this part anymore.
okay, so evaluate this one now. It says we just did the same thing. All right, we multiplied by the conjugate and then we rationalize. So we multiply by the numerator and also multiply by the denominator. That's how we do it, and then we rationalize. Okay, so, and then what is it, Praise? Oh, no problem. And then we have x minus 4 and x. Okay, I think to the recording, we can stop the recording now.